Welcome. Today we'll be building an AI to play a game called Risky Steps. The game is fairly simple. You have two balls attached by an arm. One ball is static while the other one rotates. Your job as a player is to time hitting the rotating ball to be fully inside the target step. If successful, the rotating ball becomes locked and the static ball starts rotating. If you miss or pass the target without hitting, you will lose the game and all your score. We'll be using Phaser Tree to create the game, so let's jump into it. First, we'll set up a template and remove all the template code. We'll then change the background color and game window size. So how do we start coding the game? We'll start first by spawning in an arm and two balls. Using the width and the height of the screen, we can position our arm sprite at the lower half of the screen and give it a color. Similarly, we do the same for the two balls. One ball spawns at the same level as the arm and one a bit above. It doesn't matter that they're not aligned, as we'll make them fit together in the rotation logic. Every frame of the game, we need to make sure that the one ball is rotating and the arm is following the rotation angle. Using the speed and direction of the rotation, we can update the XY positions of the rotating ball on the screen, giving it that rotation animation. Now we have a rotating ball with an arm following it around. Next, we have to spawn in the steps that the player has to climb. For that, we'll be using the initial static ball position to determine our starting step. Given the XY coordinates of that ball, we can spawn in our first step at the exact same location. After that, we must randomly keep spawning steps, each one in front of the other, until the entire screen is full. Finally, we'll add the rest of the components needed to make this a playable game. These include a score counter, which increases each time you make a successful step and resets each time you lose. Player input, which registers the player step action, which will compare the distance of the ball to the step, and if it's inside the step, we register a hit, otherwise the player loses. The loss condition, which include missing the step and letting the ball rotate past the target. Now we have a playable game that I clearly suck at. It's time to build an AI model to destroy this game. To build our AI model, we'll be using NEAT. NEAT stands for NeuroEvolution of Augmenting Topologies. Basically, this is a method of training neural networks by evolving them over time. It starts with simple networks and gradually makes them more complex by adding new connections and nodes through mutation. The best performing networks are selected to create new generations, allowing them to evolve and improve. This process continues with the networks getting better at solving a problem as they become more complex. Now we'll go through the main things our AI needs to interact with the game. Firstly, the AI needs to see. This means that the AI needs to know its own position together with the position of the target. More specifically, it needs to know the normalized Euclidean distance. To break it down, it needs to know the relative straight line distance between itself and the target. We get this by retrieving the target's XY coordinates together with our own XY coordinates and computing the normalized Euclidean distance. This would act as the input to our AI model. Secondly, the AI needs to think. This means that given what the AI sees, it needs to make a decision on whether it should try and act and attempt to hit the target and not act. This will be determined by how small the Euclidean distance is. The bigger the distance, the less likely the AI is going to hit the target. After a few generations of learning, the AI will begin to learn if the distance is too big, then it should not act, but if the distance is small, then it should try act and hit the target. Thirdly, the AI needs to move. This will be determined by the output of the neural network. If the output is above a certain threshold, in this case 0.8, then the neural net decided that the distance between itself and the target is small enough that it will successfully hit the target. Finally, we need to update the movement of the player at every frame. Now that we have all our major components in place, let's run this network with 20 players and see how fast it will learn. As you can see, the first generation of AI players are failing as they're clicking randomly, missing the target and losing. Therefore, they are not getting rewarded by the fitness function. The fitness function is what determines how the AI players are valued. The better the fitness of an AI player, the better the player is considered to be. As soon as a player clicks randomly on the target, they will be rewarded, and they will be used to create the next generation of players. This process will repeat itself as the model produces better and better players until a player that cannot lose is created. As you can see here, after 23 generations and iterations, the system has produced a successfully trained player that can continue to climb the steps forever. Thank you for watching, and please be sure to like and subscribe. Please comment down below what you would like to see next.